Hello student, today we are going to discuss about one very important interpolation known as a spline interpolation. So in this lecture, first we give a brief theoretical concept of spline interpolation. Then we discuss about one numerical example. There are basically two type of interpretation of a spline interpolation. First one is a direct interpretation, and second one is a alternate interpretation. So first thing, what is a spline interpolation and what is the need of a spline interpolation in presence of a Newton forward, Newton backward, central interpolation formulae, divided difference formulae and Lagrange interpolation formulae. So what is a spline interpolation? So first we give the definition of a spline interpolation, why its name is a spline interpolation, then linear spline interpolation, quadratic spline interpolation and cubic spline interpolation. And why cubic spline interpolation is important means in comparison of linear spline interpolation and quadratic spline interpolation, cubic spline interpolation is more popular in comparison of linear and quadratic spline interpolation. So we will discuss about these these things of a spline interpolation in this lecture. So let us start the spline interpolation. First thing, what is a spline? When computer is not used for the drawing any curve, at that time draftsman used a device known as a spline, and with the help of a device a spline we able to draw a smooth curve. What is the meaning of a smooth curve? In case of a smooth curve, the function is continuous and their first order and second order derivative in case of a cubic spline must be continuous at their knots. So that's why this one is important, and this will give extra information about the function, means a function is a continuous at the knots as well as function derivative of a function and second derivative of a function is also continuous on the knots. These two information, extra information, give a valuable information to interpolate a cubic polynomial between two known values. So let us start. What is the definition? Here I have already written the definition. As we say that device to draw a smooth curve through a given set of a point such that the slope, curvature all are so continuous. So that is, you may also say that is fx, if we assume that fx is a what? Fx is a spline curve, that is f dash x and f double dash x, f double dash x is continuous at the knots, So this one is a what? This one is a definition of a spline. So in if we try to explain graphically what is the meaning of a spline, means here we have these points, means on a x-axis there is a one point x0, another point x1, similarly here x2, and last point is xn, and previous second last point is xn minus 1. So these point is known as knots. So nodal points, also known as these are the nodal point. Nodal points, also known as are knots. So this is known as a nodal points or knots. On y-axis, if we plot the f of x, so suppose this one is a first point, this one is a f1, sorry, not f1, f0. At x0, what is the value of a function? f0. At x1, suppose the value of the function is a f1. Similarly, suppose here f2, and this point is a fn minus 1, and this point is a fn. This point is a fn. Suppose there is a, we are fit a spline fx. Fx must be a, if we try to fit a linear spline interpolation, there is a need to fit a polynomial of a degree 1 between f0 to f1. Means f0 to f1, there is a need to fit a, polynomial of a degree 1 between f0 to f1. So f0 to f1, polynomial of a degree 1. In case of a what? In case of a linear spline interpolation. In case of a quadratic spline interpolation, there is a need to fit a quadratic curve between f0 to f1, f1 to f2, and similarly fn minus 1 to fn. fn minus 1 to fn. In case of a cubic spline interpolation, also there is a need what? There is a need to fit a polynomial of a degree 3 between f0 to f1 and f1 to f2, and similarly fn minus 1 to fn. So as we know that if we have a two known values, then by forward, backward, central, divided difference, Lagrange interpolation formulae, we only able to fit a polynomial of a degree 1 between f0 to f1, because we know that the nth divided difference, nth difference of a nth degree polynomial is a constant, and n plus 1 difference become 0. So if we have a two values, then only we able to fit a polynomial of a degree 1. But if we try to fit a polynomial of a degree 2 between two known values, then there is a need some extra information. That information is a what? In case of a spline interpolation, function must, the derivative of a function must be continuous at their knots. Means fx is continuous, fx is continuous, fx is continuous, and f dash x is also continuous, between what? Between internal knots, means x lie between x1 to xn minus 1, between internal knots. And in case of what? If we try to fit a quadratic curve between f0 to f1, if we try to fit a cubic curve between f0 to f1, then also there is a need one more condition. That condition is what? F double dash x is also continuous, between x lie between x1 to xn minus 1, and fx is continuous between x0 to xn. So, as the degree of a polynomial increases, this means this condition means f dash x, f double dash x, f triple dash x means one condition, two condition, three condition, the number of conditions also increases. In other words, if we try to fit a linear spline, linear interpolation, which is equivalent to the linear interpolation, piecewise linear interpolation. So, there is no need of extra condition. It must be necessary, means a spline interpolation, a spline curve must be a continuous at each nodes, at each nodal points. But if we try to fit a quadratic curve between two known values, two nodes, then fx is continuous at their nodes, but f dash and also f dash x is continuous at their internal nodes. And if there is a cubic polynomial, we try to fit a cubic spline, we try to fit a cubic curve between two known values, between f0 to f1, then there is a need to satisfy three conditions. Fx is continuous at their nodes, and f dash x is continuous at their internal nodes, as well as f double dash x is also continuous at their internal nodes. So, basically these three type of spline interpolation is more popular, and among these three, cubic spline interpolation is most popular. So, if we try to categorize the spline interpolation, there are three type of spline interpolation. Spline interpolation, if we try to write here spline interpolation, first one is a linear spline interpolation. Second one is a quadratic spline interpolation. Third one is a cubic spline interpolation. Means we try to fit a linear curve between two known values, then this one is known as a linear spline, and you may also say linear spline as a piecewise linear interpolation. And if we try to fit a quadratic curve between two known values, then we say that quadratic spline interpolation. And if we fit a cubic polynomial or cubic curve, then we say that there is a cubic spline interpolation. Interpolation means we try to fit cubic curve between f0 to f1, then for any unknown values between x0 to x1, be able to find the values of unknown between x0 to x1 in term of a cubic polynomial. So mathematically, how we define this one is a what? Graphical interpretation of a spline interpolation, or you may say a spline, how we fit a spline curve, fitting of a spline curve. So what is the mathematical definition of a spline interpolation? So a spline function, as here be written some basic terminology, means initial mathematical definition of a spline. A spline function of a degree n with nodes xi, I ranges from 0 to n. I ranges from 0 to n. I ranges from 0 to n means this one means how many number of nodes we have? We have n plus 1 nodes. We have n plus 1 nodes. Okay. We have n plus 1 nodes. And what is the degree of a polynomial? Degree of a polynomial is a n. Degree of a polynomial is a n. Satisfy the following property. First property is what is the first property? First property is if we assume that fx is a what? Fx is a spline function. Fx is a spline function. So rather than interpolation, we may say that a spline function, we try to fit a spline function, linear spline function, quadratic spline function, and cubic spline function. So what is the first property? Fx equal what? Fx equal what? Fx equal, we know that Fx equal Fi. Fx equal Fi for x lie between x0 to xn. X0 to xn. Now x0 to xn, x lie between x0 to xn. So here fxi, you may also say that this one is fxi. Here we denote this one is not fx, fxi. Fxi equal fi. Second one, fxi is a polynomial of degree n between what? Between each class interval, between degree n for x lie between xi minus 1 to xi, and I ranges from 1 to n. I ranges from 1 to n. What is the meaning of this one? Fx is a polynomial of a degree n. If I equal to 1, then x0 to x1. I equal to 2, then x2 to x1, x0 to 1. I equal to 2, then x1 to x2. Means between x0 to x1, there is a polynomial of a degree n. Between x1 to x2, there is a polynomial of a degree n. If n is a 1, then linear spline. If n is a 2, then quadratic spline, and n equal to 3, then cubic spline. And third one, fx is derivative of a fx so how we write this one? N minus up to n minus 1 derivative up to n minus 1th derivative of fx is continuous between for x is greater than xi to what? With for not in this way, for x ranges from xi ranges from for x BC for x tends to 1 to n, 1 to not n, 1 to n minus 1 means internal knots. So this one is a what? This one is a mathematical definition for any spline function. If n is a 1, if n is a 1, then linear n is a 1, then linear 2, then quadratic 3, then cubic spline function, So n equal 1, then linear spline function, n equal 2, then quadratic spline function, and n equal 3, then cubic spline function. So now question is why, what is the quadratic spline function? As we say that in a case of a linear spline function, n must be a 1. So there is nothing else new in if n is a 1, then what will happen here? fxi equal to fi between x0 to xn. Fx is a polynomial of a degree 1 between each class interval, and up to n minus 1 means fx is a continuous at internal knots. So obviously this one repeat this condition in case of a linear interpolation. So there is a need of a first two condition in case of a linear spline function, if we fit a linear spline function. But if we try to fit a quadratic spline function, then if we try to specifically mention what is a quadratic spline function, what is the property of a quadratic spline function, if we try to define mathematically what is a quadratic spline function. So here we write a quadratic spline, and a quadratic spline satisfies the following properties. First one is a what? First f of xi equal to fi. For what? For x ranges from x0 to xn. You may say xi, not x means xi ranges from x0 to xn. Second one, fx is a polynomial of degree 2 between 2 for x ranges from xi minus 1 to xi I ranges from 1 to n. I ranges from 1 to n. Except first and last interval. First and last interval. First and last interval. Third condition, f dash x is continuous for internal nodes, means x lie between fx is continuous for xi I ranges from 1 to n minus 1. 1 to n minus 1. So, here there is one limitation of a quadratic spline. That limitation is what? That limitation is a polynomial of a degree 2 except what? Except first and last interval. Except first and last interval. What is the meaning of this one? Meaning of this one, if we try to fit a what? Try to fit a quadratic spline, means here there is a x0, x1, x2 and x3. Suppose there is x4 and corresponding value with the f0. This one is a f0, this one is a f1, this one is a f2, f3, f4. We fit means a quadratic polynomial at internal nodes, means between f1 to f2. Between f1 to f2 we fit a quadratic polynomial, and f2 to f3 we also fit a quadratic polynomial, but except first and last interval. In a first interval means x0 to x1 and last interval x3 to x4 we doesn't fit a polynomial of a degree 1. So, this one is a what? This one is a limitation of a quadratic polynomial. There is no any such limitation in a cubic spline function. That's why cubic spline function is more important, more popular in comparison of a linear and quadratic spline interpolation. Because in a cubic spline interpolation, in each class interval, we fit a polynomial of a degree 3. That's why cubic spline is a more popular in comparison of a linear and quadratic spline interpolation. That's why in most of the syllabus there is a cubic spline interpolation is mentioned. Linear interpolation and quadratic spline interpolation is not mentioned in the syllabi. That's why, because there is in application point of view, cubic spline interpolation is more applicable, more application oriented in comparison of a linear. Linear is nothing else. This one is a piecewise linear interpolation. So, nothing else new in a linear spline interpolation. In a quadratic spline interpolation, we fit a polynomial of a degree 2 using a 2 known values with the information f dash x is a continuous at the internal nodes. But there is a limitation at the first and last node, first and last interval we are not going to fit a quadratic polynomial. But in a cubic spline function there is no any such limitation. That's why cubic spline interpolation is more popular in comparison of a linear and